right, let's see if you guys remember, because a lot of people forgot. Because for some reason, I still see earbuds in. I still see people looking at Tinder during my class. What'd I tell you about that? Okay? Seriously. Game on, stay away from it. Okay? Seriously, you don't need a dating app. Bro. You don't. Oh. That's all you need right there. That's all you need right there. Okay? You don't need a dating app. Okay? All right, so that being said, I know no one has earbuds in right now because they took them out, put them away, and charge them, right? Okay, good. So I have to have you guys use your phone during class. Was there a certain app I had you guys download? Numworks. Thank you very much. Numworks is a wonderful graphing calculator. It is wonderful. It is great. It is amazing. If you don't have it on your phone, can you use your laptop? Yeah. Yes, you can. You can use your laptop and you just go to Numworks. Just search Numworks. Just internet search Numworks, right? You got it? Yes? All right, because everyone's going to need it here in a moment. So I'm just making sure everyone's got it. So right here, let's go ahead and get started with our notes. He did any of the things behind you. This is page number 11 in my notebook. Okay, there's objectives. Now, points in ordered pairs. Now, I'm hoping you guys actually are trying to follow along because the quadrant thing is super important because when we start talking about quadrants, you need to know where something ends up at. So in right here where the X and Y come together, that is called the origin. It's also on your notes, so you can actually see it there. You don't have to write it out. That is my origin. Okay, that's where the X's and Y's come together at 0, 0. Now, to the right on the X axis is all positive numbers. These are all my positive numbers. Left is the negative. Thank you. So, going this way is my negative. Then when we get to the y-axis, okay, when we get to the y-axis right here, up is going to be positive numbers. And down is negative. So positives and negatives, that's important. Okay, when we start talking about ordered pairs, it is like giving you a direction, a roadmap. If I said, hey, I want you guys to go from this spot right here over to Deuce Rose, what are you going to do? Deuce Rose, yeah, that way, right? So you're going to go that way, that direction. So in my, okay, so you're going to take a right and go, I don't know, what, like half a mile that way? That way. Yeah, that's 7th Street over that way. 7th Street's that way.
That's what.
Yeah.
It's that way. It's that way, and then this way.
Yes, there it is.
That way.
And then this way, right?
Yeah.
So we go that way, then this way. So that's the same thing that we're going to do with these ordered pairs. So I'm going to take a right. Okay, I'm going to go head towards Deuce Rose, and then I have to go down a little bit, right? So from there, I go down more. So that would be like saying the X coordinate and the Y coordinate. So I'm taking a right. Okay, that's going to be like my X. I'm going that way, and then I go down. That would be like going my Y coordinate. So that's what we're trying to get at here. So we have an X and a Y. Hey, Diddy. We actually do have seats left over. You want to take one of these? All right, good. I know. Still, earbuds in. Now, points ordered pairs. Each point in the rectangular coordinate system corresponds to an ordered pair of real numbers. X, comma, Y. X, comma, Y. Your ordered pair is in alphabetical order. Do not screw that up. Alphabetical order. Because that's going to be the key. That's probably going to be one of the things that just about everyone is going to make a couple mistakes on. I don't want you to make those mistakes. Because it goes X, Y, ordered pair, alphabetical, right? your earbuds away too? Oh yeah, kind of forgot already. No. Okay, so look at the order of pairs. So we have -5, 3. -5, so that starts with my x coordinate. So we said x is, okay, the -5 on my x is going to go to the left. -5 on the x is going to be to the left this way. And then the 3, that is a positive 3. Nope. Up, because it's now the y coordinate, right? Y is up and down. X is left and right, y is up and down. So from there, I need to go up 3, and that's going to give me my -5, positive 3. Now, when we go back and look at the other one, the converse of that, this one now says positive 3, -5. So positive 3, so my positive 3x moves to the right 3, to the right 3, and down on the y. Okay, there it is right there, and it puts me right there. So if you think about it as going left, right, up, down, it is giving me directions of going one place to the other. That's what we're trying to get at. Right here it says the figure shows plot or locate the points corresponding to the order pair. So when you see the word, keyword is going to be plot. That means you're going to put that point on a graph. Okay? Or locate the points on the graph. That's another thing. You're going to put it there. Or you're going to find it there and tell me that location. That's what those mean. Plotting points in the rectangular coordinate system. Plot points, blah, 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 blah. I think the next one has the graph. Nope. Damn it. I could have swore I actually did put in a graph here.
It's on number 8.
I did put it there? On page 8? Oh, I know, but that's for this one. I thought I put another graph just for... Yeah, I know. I screwed up here. Anyways, so you guys are going to put one because yours is going to be so much better than mine because you have great drawing skills, so much better than mine. Mine are horrible. All right, what's the biggest number I have? 5? Okay, so 0, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. So I made a 5 by 5. So it's a 5 by 5. So 5 positive, 5 negative, both x and y direction. Now let's go ahead and start putting some of these on here, and we're going to label them. Labeling is key. Labeling them is key. Is there a question? You good?
Oh.
Did you really just sprain your thumb, give me a thumbs up? Wow, okay. Or was it your elbow you just sprained from, like, oh, wow, horrible. Okay. You need to go work out some more. Anyway, plot the points. A, -3, positive 5. So that means it's to the left 3 and up 5. So let me see. 1, 2, 3, 3, 4, 5, right here. And I'm going to put that point and I'm going to label it what? A. Good job. Look at that. Good job. Next one, B. It is, so B, I'm going to the right, and then 4 down. Because it's negative, it's going to go down. P. Diddy's here.
Yes.
Oh, you seriously?
Yes.
Oh, okay.
What did I do?
Oh, dang it. Dang, Puff Daddy. All right.
Homie.
All right, so 2 and then down 4.
Oh, I know exactly what I did.
What? Okay. I was going to go to school. But then I got now I'm getting escorted out of class, and I know why. I'm a freaking horrible person, ain't I? Anyway, all right, C. It is positive 5, 0, right? Positive 5. So that means 5 to the right. And what am I doing if it's 0? Leave it right there. I'm not going up. I'm not going down. Just going to leave it right there. Right there. And I'm going to label that C. Good job. D says -5, -3. So that's 5 in which direction? To the left and then down 3. Very good. So E, 0, 4. So where am I going? Stay at 0. Where am I going for? Oh. Remember, this one is, yeah, there we go. So this is left and right, and this one's up and down. Okay, so I'm not moving left and right at all, but I am going up 4. And call that one E. Letra E. I don't know. Is that how you say E? A. That's how you say A. A. How do you say A then? A. E. E-A. What about A?
Sports.
How do you say A? It's in the game. All right. F. Where's F? 0, 0. Stay right there. Also referred as to the, what do we also call that? Origin. Thank you very much. Good job. See? You know what you're doing. Just needed a little bit of refresher. Graphs of equations. A relationship between two quantities can be expressed as an equation in two variables such as y equals 4 minus x squared. A solution of equation in two variables x and y is an ordered pair of real numbers with the following properties. When the x coordinate is substituted for x and the y coordinate is substituted for the y equation, we obtain a true statement. The graph of an equation in two variables is a set of all points whose coordinates satisfy the equation. Anyone understand what that means? Nope. Probably not, right? No, because he was looking at his phone the whole time for some reason. But, you ain't heard it from me because I'm with the gospel. So, what it means is any value that you have on x, you're also going to have a y. And where's it going to end up at? On the line. That's what that means. Any value you have for an x, you're going to have a y value, and it's going to end up on the line. So, graph right here, where we have 4 minus x squared, selecting integers for x starting with -3 and ending with +3. All right, I'm going to bring up my numworks. All right, so a couple things, super neat. Okay, so we're going to do some graphing here. So I'm going to arrow over, hit OK. Add element. My element is going to be, I'm just going to go OK. Okay, so it's going to be a y equals, isn't it? Arrow down to y equals. And you can delete that one. So y equals what? 4 minus x. So got to find x, which is right up here on top. And it's got to be squared. I got a square right here. Okay, good, right? Hit OK. And then what do I want to do with that?
Wait, where's X?
X is right here. So see where this power off is? It says X, N, and T. Right here. Does that make sense? Anyone else? So now that we have this calculator is super easy for many reasons. So let's go down, and I'm just going to say, let's plot graph. Okay, that's what it's going to look like. So it touches here at 4, touches here at x is -2, when x is +2 here. Okay, so that's what the graph's going to look like, right? Now, I want you to arrow over. Wait, hold on. Go up, up, right here. It says right here, this is graph. We want to see the table. So highlight table and hit OK. Dang. I know, right? There. Okay, so, but I don't have any negative numbers on there. I have to start at -3, right? So just arrow.
Yeah.
Okay.
Exactly.
No, we could just go set interval.
X start negative.
X start. Okay. We want what numbers? -3, right? So I'm going to put -3 there. So let's see. -3. Go down, and that one's going to be a +3, isn't it? Okay. There we go. And steps. Now, what step means that it's going to be every number in whole numbers. What if I put 0.5 as a step? What if I put 0.5? Yeah, it would be every half of a number, right? So it would be -3, -2.5, -1. But let's go and confirm. Hey, look. Did this do everything for me?
Yeah.
Yeah. It just did everything for me there. So let's go ahead and plug in my numbers. So you guys going to help me read this off. So at -3, my answer was -5. At -2, 0. -1, 3.
3,
Very good. Thank you. 0,
4,
1,
3,
2,
0,
and
-5.
good job. It's almost like you guys learned something right now.
Hey, real quick, when y'all get to my math lab and y'all are doing this on the homework, that table may not be displayed for you. It may just say starting with -3 and ending with -3. What you see for the x values is what you want to use when you see the question.
Yeah, it's going to come up here in a minute, and it's going to say where to start and end. Okay, so now, do you think you guys could actually do that on your own now? What steps did we do in the calculator? Did you write down the calculator steps on how to get there? Okay, so do you think you should make yourself a note right here on these notes, right there on those lines off to the side, and say, hey, NumWorks calculator, where did we enter this in? Where did we start at in my NumWorks? Okay, we started at graph, didn't we? Okay, we started with grapher. And from grapher, we entered the values, right? Or added element. Okay, you put it in there. And then we went to graph. And then what else we do after that? We went to table, didn't we? Okay, so that would be a very, very good note for yourself later on. Ooh. See? Good. All right, you got this. Okay. See, he doesn't have faith that you know what we're talking about. Yeah. Okay. Now, this one right here, it says graphing it. So let's go ahead and graph it, because did your calculator give you a graph? Yeah. But it also gave you some points to put on. So at -3, my answer was -5. Okay. At -2, my answer was 0. At -1, my answer was 3. And at 0, my answer was. At 1, my answer was. At 2, my answer was. And at 3, my answer was. All right, look at that. So what do you think I should do with all those dots that I just put there? Yeah, connect the dots. Es muy bueno. Yes, es muy, muy. Okay, let's keep going then. Functions. Function, function, function. If an equation in two variables, x and y, yields precisely one value of y for each value x, we say that y is a function of x. The notation y equals f of x. Now, your calculator, the NumWorks calculator, will actually do y equals or f of x equals. Most calculators will not do both. Indicates that the variable y is a function of x. The notation f of x is right, f of x. So it means the same thing. It's either y equals or f of x equals. They mean the same thing. Application involving function notation. Tailgaters beware. If your car is going 35 miles per hour on dry pavement, your required stopping distance is 160 feet, or the distance the average person walks in 35 seconds. At 65 miles per hour, the distance required is 410 feet. The distance the same person walks in a minute and a half. Figure A, next slide, shows stopping distance for cars various speeds on dry roads and on wet roads. Figure B, next slide, uses line graph to represent stopping distance at various speeds on dry roads. Here we go. We got our two graphs. Okay. There we go. So here is my graphs. This is the data that we have for this. So at 35, okay, at 35 we have dry and wet. So every once in a while it rains here in Phoenix and everyone loses their freaking mind because they stopped learning how to drive a while ago. It's weird. Anyway, stopping distance for cars on dry pavement right here. So if you notice, what's happening as it's going up? What's happening as that's going up? So the faster you go, a lot further, right? But is it growing on a straight line? No, it's not. And that's what we're trying to get at. Is it growing on a straight line? No. It is actually has an exponential growth. Okay? There is a curve to it. So it's actually getting longer and longer for each one. Use the line graph to estimate a car's required stopping distance at 60 miles per hour on dry pavement. Round to the nearest 10 feet. Okay. 60 miles per hour. So go find dry pavement, 60 miles per hour. That's this graph right here on the right for everyone following along. Okay, because for some people are not following along. They're staring at their phone still. Okay. Now, dry pavement, find 60. I got that right here. Okay. Where is it connect my line? Right about here. Okay, so if you look, it's in between 300 and 400, right?
Yeah.
Okay. Is it more than halfway? Yeah, it's about, it's a little bit more than halfway. So if it said round to the 10, you would say what? Would you say 350? 3, is it higher? Is it closer to 400?
Closer to 400.
Yeah, it'd be closer to 400, so it would be more than 350, wouldn't it?
Yeah.
Let's say it's
380.
380 or 360. 360, because it still looks like it's about close to that middle, right?
370.
Okay, so about 360. So let's go ahead and see what we have. So it's going to be about 360 feet. We're just pulling in the values from the graph. So your estimations should be pretty, it's pretty big. I'll show you how to get exact answers. As long as you don't have earbuds in, so you're not listening to or ignoring me for some reason. Because you ain't heard it from me, because I went to gossip, because I don't have students that don't do that.
Don't have students that don't.
Yep, I don't have students that would do that. None of my students would do something like that, right? Or just try to hide it with their hair. Would they? Would they? Anyway,
That's crazy.
so the function right here, model a car's required stopping distance, f of x in feet on dry pavement, traveling at x miles per hour. Use this function to find the required stopping distance at 60 miles per hour. Round to the nearest foot. That means to the whole number. So this is what we're going to do. Your function is going to look like this. F of 60. And so every place that we have an x value, I'm going to replace that with, say 60. Good. Equals 0.08. That's a point. 75, open parentheses, 60, close square, minus 0.4, open, 60, close, plus 66.6. Now, we're going to use our numworks calculator again, but now we're going to use a different function of our numworks. Now this time, so right now we're in the grapher. I'm going to hit home. Okay, let's go and do calculations. Now we're going to do calculations. And just put it in just as you saw it. So that was, actually, let me see if I can split screen so I can see both here. Wrong side. There we go. So I'm going to split screen here. So I have, now, if you plug it in here on the calculations, do not put the f of x or the f of 60 here. Don't put that there. Start here after the equal sign. That's where you start there. So I'm going to have 0.0875 open, 60, close square, minus 0.4 open, 60, close. What was after that? It was it plus? Yeah, plus 66.6. Okay, so as long as you guys are following along, you can plug it in just like that. I know my screen doesn't have it all on there, but just so you can see it. Does anyone need help getting there?
I got the answer.
Okay, good. I'm trying to make sure everyone is getting this for the calculator right now. Because knowing how to use the calculator is going to be key for this one. Does anyone need help here? Six zero. Close. Square. Right. And it said round it to the nearest foot. So that's a whole number. That's a whole number. So I'm going to hit enter, okay. So 357.6. Now the whole number, I look at that 0.6. What is the 0.6 going to do? It rounds up. So that means my answer has to be 358. There we go. So my answer is going to be 358. So F of 60 as my answer is going to be about 358 feet. Make sense?
Yeah.
Okay, let's keep going. Hopefully we can, actually, how many more slides we got? We got a couple more? Alright, it's fine. So this is what I'm going to do. I'm going to leave off here. We're going to pick this up on Monday. Okay, I want to give you guys some time to start working on this in your MyLab. So where is your homework going to go? Page number 10. So you're going to write down the problems on page number. Good. All right, don't forget, all like, share, and subscribe. Hit that notification button. Support my channel.